Hello, today we're going to try the harder of the two virtual earthquakes. The first thing I'm going to do is go in here and figure out virtual earthquake. This is the one I showed last time. This other one right here is sciencecourse.org EEC earthquake. This is the one I want to demo today. This one is a little bit more difficult. Only because it's got more variables, more things that you can actually test. They do have a demonstration which you could watch, but I figured the demo I'm going to do right now. They offer tutorials, which again I'm going to be doing that. For instructors, you can set up a site where they can actually email the sites, and you can find out some other things they need, and you can do it in Spanish if you wish. The main activities, I'm going to go into time travel. You need to make sure that your pop-up blocker is off, because you see it opens up in another window. You can maximize this if you wish, or you can leave it the way it was. I'm going to go ahead and maximize it. So go ahead and click Start. Gives you a little bit of a tutorial while the Java is loading in the background. Shows you that there's going to be a map, there's going to be information you need to fill in, these are the buttons you pick, and instructions if you need it. And here they are. The first thing you do, if you take a look at this, well, here's the actual site that you put your data in. It comes up with the data off the computer. You type in whatever you want. You're going to have to figure out, in terms of stations, station 1, 2, 3, 4, and 5. Figure out the distance. Figure out the lag time, which will give you the distance. You're going to verify that data. Then you have to come down and answer 2 questions before you can get through this part. So let's move the stations. First thing you do, there's the epicenter. That's the point where the earthquake takes place. So they tell you that. And you can move these stations. You can move them close, but that's as close as you can get it. You can get them as far away as you want. You can leave them out in the water if you want. I'm going to put one there, and I'm going to put one right about there. And then you see this triggered the eruption pulled out. So I'm going to trigger the eruption, and there'll be a noise. So that was the earthquake, and you notice now they'll get some more buttons. So the first thing, we can click this, and it says time travel. So what I'm going to do, actually I don't have any idea what that one's doing. This is the one we want. Remember, we have 2 packets of waves, actually 3. The surface waves aren't showing, but we get 2 body waves. The primary waves, which come in, there's very little motion if anything. Here comes the first primary wave, which compression changes the shape of the earth. It settles down, and then we have the up and down waves, the shearing waves that come through, and they'll actually set up. But what we want is we want this first one and the last one. So it says start dragging here. So I'm going to put my mouse down there, and I'm going to drag it till I see the first S wave, and this is station 1, and for station 1 I'm going to say it's 23.1 seconds away. Then I need to go up and get station 2, get station 2, and do the same thing. Click at the beginning of the first P wave. Looks like I didn't get it as close as I want, and the closer you get this, the better off you're going to be at the long run. Station 2 looks like it's 18.1. Station 3. And you can, if you don't like the way they are, you can magnify them up to 1,000 times, a little big. Try 700. And start at the first one, go to the last one. So station 3, 40.9. Station 4 goes back to 100%. Station 4 comes in at 48.3. And finally station 5, too big, too big. Station 5 looks like 10.4. Okay, so we've got that all set up. Next thing we want to do is we want to figure out the distance. Okay, so you can do these in different ones. You could actually do it in numerical order if you want to. I like to actually grab onto this one and go to the very first site and try to get it in the middle of the box. And we'll say that station 5. Make sure you do the stations because you're not doing this in order. Then we go out to station 2, 177, station 1, 223, station 3, 401, and then finally station 4, 474 kilometers away. Okay, so time, there looks like there's a relationship between this. It's nice of them to actually do all this for you. And then we can verify the data. Okay, it looks like it didn't like, what didn't it like? Because that's station 4. That's what it was. Good lesson to learn. Make sure that you put them in the right place. Okay, so we got that. Now it says plot the points. So what I'm going to do now is I'm going to pick the one that they're actually, the one next to it. So, plot the points, sorry. Okay, so it says I've got 223 kilometers, I've got 23.1 seconds. So I'm going to go out to 223. Well, let's go down to 23.1. 223.1, 177, 18.1, 401, 4090, 474, and 48.3, and then 101, 10.4. Verify them. Now I'm going to pick the best fit. And all I do here is I take this blue line and go down here, line them up, try to get the smallest error of squares. And 2.8, 2.5, 3.1, 2.4. If I can get that 2.4 again, I'm going to take it. 2.4, verify your slope. Looks like I got that. Okay, and then the last thing, answer the two questions. Two questions are: 1, what is the distance for a station if the epicenter is 33 or 30.3? So take it up to 30.3. Answer there is 294 kilometers. And this one says, given 186 kilometers, what's the time? Down to 186, that's 19.2. And we go down and we verify that. And it looks like our answers are correct. So we can go on to the next activity. I'm going to quit this. I'm going to go ahead and say save it. Saves it on their server. Go down to epicenter and magnitude. Actually, before that, you can go into latitude and longitude. I'm not trying to teach that in this one. You can also go into lag time, which explains why the P and the S waves are not in the same place and why there's more time the farther the distance from the epicenter. Now I'm going to go to epicenter and magnitude. Seismographs can actually be set up in one of three ways. You can actually get vertical motion where the land goes up and down. You can get north-south motion if the land goes north and south. You can get east-west motion if the earthquake causes the land to go east and west. We're not going to pay attention to that in this activity, and they don't really pay attention to it either. So you can take a quiz. We're going to go ahead and start the activity. Again, we're going to be given a map. We're going to be given keys that we go through. We'll be giving spaces that we have to figure out questions. Loading the Java. First thing we do is we figure out the epicenter. So we're going to trigger the earthquake. They give you a whole bunch of stations. This is going to get loud too, and you're going to hear breaking of dishes and things. And I guess glass panes. Okay, so we've made the earthquake. We can actually pick a map if we want to, but I'm going to go ahead and go right into this. And we're doing sort of the same thing we did before. It's a little small, so I'm going to enlarge it. We start at the first P wave. We go to the first S wave, and Mikey D. We can pick any station we want. I'm going to go ahead and pick station 1 because it was kind of small. Okay, the SP seconds, 25.2. And notice we only have to pick 3 for this triangulation. So what I'm going to do is I'm going to try to pick 3 that are different. That's a little close. There's one that's completely different. I'm going to expand that 1,000 times. And I'm going to pick this one. First P wave to the first S. This is station 3, and that was 51.4 seconds. And now let's pick one that actually has big waves, if we can find one. That's good. Let's make that 25%. These guys may be a little close. The first S wave's about right there. And I'll say station 7 is 7.5 seconds away, or 7.5 seconds of lag time, excuse me. Okay, for this one we're trying to figure out the amplitude. We have actually a wave height. Amplitude is half, so it's basically from the middle up or from the middle down, half the wave. I'm going to enlarge this one way too much. Let's try 300%, let's try 200%, let's try 150, let's try 100, let's try, you see what I'm doing? Okay, so can't really see that top part, but I can see the bottom. I'm going to go all the way down and then back all the way up. So I'm going to say station 7 has 33 millimeters of amplitude. Station 3 starting there, going up to looks like 0.4, looks like 0.4, and then station 1, and this one actually starts at 0, so you can go up and hit this one up here for 3.7, go down and hit that one up there at 3.6, so I'm going to say 3.7. Good idea to check both of them. Okay, now we're going to figure out distance. Based on 25.2 seconds, they traveled 245. 51.4 seconds was 502. And 7.5 is 73. And then for magnitude, actually for epicenter, now we're going to start with station 1, and we're going to draw a circle that is 245 away, and really that's the 245 right there, and that's not the one we want. We did that. Okay, start dragging. We're going to figure out where the epicenter is. Okay, and then we go to station 3. That one was 502. Okay, and the reason we need 3 stations, the earthquake could have happened right there, or it could have happened where these two intersect up here. I will tell you that you can't scroll up or down, so this is where the earthquake was. So when I do 7 and I come out with 73, it better be like right there. And then all you do is you no, I have to click this to get it. I need this little E, and this is where the epicenter is, and I'm just going to put it where these 3 circles seem like the happiest. And then I'm going to go over and figure out where it is on the planet. They actually, this is pretty much all in Southern California, so it's somewhere between, a little lower than 33 north, all the way up to about 36 north. Looks like we have 1, 2, 3, 4 in there, so we go 15, 30, 45, and 60 up. We have 1, 2, 3, 4, same thing this way. This is located at 33 degrees because it's above that. 33, there's 15, there's 30, there's 45. I'm going to say that's about 50 degrees north. And it is 117. Gotta scroll down a little to get there. 117 and I gotta scroll back up. 117, that would be 15, so I'm going to say 05. And that is west. Verify our answers. Fill in all the data. I haven't done magnitude. Okay, last thing we got to do is we got to figure out waves traveled this far enough to get this lag time. They traveled this far. They were this big. How strong does that say? And you can see we need distance and we need amplitude. So our distance for our first one, we'll start at this one, 73, because we're close to that. 73, and we had 33 millimeters. So we read this 4 point, and this is let's see, 1, 2, 3, 4, 5. So 4.123, 4.3 is what this one says. 4.3 magnitude. Let's move this distance up to 245. Let's move the amplitude down to 3.7, and looks like we're at, believe it or not, same thing, 4.3. And then let's put this one up at 502. And let's put this one, to get it down to there, we better be a lot lower. 5.2 is 0.04. And what do you know? We still have a 4.3. Okay, now we can verify our answers. Our site is complete. Click here to continue. Mikey D. Forest. Park. How about Park High School? Woodbridge, Virginia, and our class code given by the instructor. We didn't set that up. Submit it, and here is our notification. And are you sure you want to exit? So this is what you'd print out if you needed it. And so now we're doing an assessment quiz. It says use the mouse to measure. And looks like we have 28.7. Then we measure I got to tell her which one I want. 5.5, 5.5, continue. Okay, what's the distance? 36 seconds. 351. I'm using the Richter scale, 192. And 31. Looks like 5.0. Suppose a 3.7, so there's 3.7, was 173, 3.7, which is right there. Let's say had 1.96. You can see there's 3.6, 3.7. They give us this one. We just got to figure out how far we got to drop it. Earthquake is 91 away. Resultant is 0.15. Magnitude is exactly 1. Let's see. If the earthquake is 91 away from the seismograph, the resultant maximum wave amplitude is this. What's the amplitude of an earthquake whose magnitude is exactly 1 greater than given? So this is a 2.1. We want to go up to 3.1. So that would be 1.38. Let's continue. Okay, we've got to figure out latitude for A. Looks like it's right on 36. And it's also on 121 west. And this one is in between, so 34 point, that would be 30. So I'm going to say 3420 north by 111. And that would be 30, let's say 40 minutes of west. Seismogram above have tracings of seismogram. Which one is closest to the recording station? It's got to be this one because the P wave got there first. Bottom. Which earthquake has the greatest magnitude? This one's close, so it should be big. This one's farther. That's the farthest one, and it still is the biggest, so I'm going to say the top one. You went through 90% of the questions. So, got that one wrong. Wonder why I got that one wrong. This is what you'd print out, and you close it, and you're back to square one. Okay, thanks for stopping by. Bye-bye.